A ball is thrown straight downward with a speed of 0.50 meters per second from a height of 4.0 meters. What is the speed of the ball 0.70 seconds after it is released? So we know the initial velocity of the ball is 0.50 meters per second, and that is straight downwards, so I'm going to consider that to be negative. We know the acceleration due to gravity is also downwards, 9.8 meters per second squared. We want to know the final speed of the ball after 0.70 seconds. We're also told that the ball is dropped from a height, or thrown from a height, of 4 meters. And this is important because it's possible that by 0.70 seconds after it's released, the ball has already hit the ground and its velocity is 0. So that's something that we need to check. We need to know how far the ball has fallen after 0.70 seconds. So we can use this equation. Displacement is equal to initial velocity times time plus 1/2 times acceleration times time squared. So the initial velocity is negative 0.50 meters per second. The time is 0.70 seconds. The acceleration is negative 9.8 meters per second squared. And again, the time is 0.70 seconds, and that'll be squared. Now, if you evaluate this using your calculator, negative 0.5 times 0.7 plus 1/2 times negative 9.8 times 0.7 squared, you should end up with negative 2.7-ish. You could probably round this to negative 2.8 meters. So this is the displacement at 0.70 seconds into this ball's downwards travel, which means that it hasn't hit the ground yet, and we can use one of our other equations to find its speed. So remember that final velocity is going to be equal to initial velocity plus acceleration times time. The initial velocity is negative 0.50 meters per second. The acceleration is negative 9.8 meters per second squared. That'll be multiplied by the time of 0.70 seconds. Now if you evaluate this using your calculator, negative 0.5 plus negative 9.8 times 0.7, you should get an answer of negative 7.36 meters per second, but keep in mind that we only want to have two significant figures, since all of these values that are being multiplied together only have two significant figures, and then when we add everything together, we want to keep the same amount of decimal places as the number with the least decimal places. So here we should have two significant figures and only one decimal place. Here we'll have two significant figures with two decimal places, so in the end we should have two significant figures with one decimal place. So we're going to round this to negative 7.4 meters per second as the final velocity. This includes the direction, which is downwards, but if we're just talking about the speed, which is the magnitude of velocity, we can get rid of the negative sign and call it 7.4 meters per second.